You know, I'm always up for a good brain teaser.
Mm-hmm.
And you wanting to dive into AI intelligence.
Yeah.
That's like the ultimate puzzle, right?
That's a good way to put it.
It's not just about, building machines that can do things.
Right.
It's about like cracking the code of intelligence itself.
Absolutely. And I think one of the most exciting aspects of this field is that it forces us to confront our assumptions about what intelligence actually is.
Right. Like we're so quick to slap that label, the intelligent label, on anything that can like beat us at a game or, solve some complex equation.
Right.
But Francois Chollet, this AI researcher at Google,
Yeah.
he would probably say, hold your horses.
Uh-huh.
His paper on the measure of intelligence, it really challenges our obsession with skill as like a measure of true intelligence.
Yeah, what's fascinating about Cholet's argument is that he goes beyond just critiquing those like flashy AI demos.
Right.
He digs into the very heart of how we design and evaluate these systems.
Mm-hmm.
And he argues that we often fall into the trap of gaming the system.
No. Okay, so let's unpack that. What does he mean by gaming the system?
So imagine you're training an AI to identify different types of flowers.
Okay.
You feed it millions of images of roses, lilies, tulips, you name it.
Mm-hmm.
The AI gets really good really fast, thinking, wow, this thing is a botanical genius.
Right.
But here's the catch. What happens when you show it a picture of a flower it's never seen before, say a rare orchid?
It breaks.
Ah.
I bet it freaks out.
Uh-huh.
It's only as smart as the data it's been spoon-fed.
Exactly. It might have mastered that specific task it was trained on,
Right.
but it hasn't actually developed a deeper understanding of what makes a flower a flower.
Mm-hmm.
Charlotte argues that this kind of overfitting to training data is one of the ways we fool ourselves into thinking AI is more intelligent than it actually is.
It's like that classic experiment where they showed a pigeon a bunch of pictures and it learned to peck a button whenever it saw a tree.
Yeah.
And people thought, oh, the pigeon understands trees. But
Yeah.
it turns out it was just recognizing patterns of light and shadow.
Precisely. And the other way we game the system, according to Cella, is by inadvertently giving AI systems too much help in the form of priors.
Priors. Like the things we already know.
Think of it like this. Humans are born with certain innate priors, like the concept of object permanence.
Right.
The idea that objects continue to exist even when we can't see them.
Mm-hmm.
These priors, while incredibly basic, give us a huge head start in understanding the world.
Right.
But if we build AI systems with like a ton of pre-programmed knowledge specific to the task at hand, are we really testing their ability to learn and adapt?
It's like giving someone the answer key to a test and then congratulating them for getting an A+.
Exactly.
So if just being really good at a very specific task isn't a sign of true intelligence, what is?
Right.
You mentioned Cholet has some thoughts on that.
He does, and this is where things get even more interesting. He argues that intelligence isn't about acing predefined tasks. It's about two key factors, efficiency and scope.
Efficiency and scope. Okay, I'm intrigued. Tell me more about these factors.
So when it comes to efficiency, Cholet is talking about how quickly and effectively a system can learn new skills from limited data. He draws a parallel to the G factor in human intelligence,
Okay.
which is our general learning ability.
So instead of needing millions of examples to learn something new, an intelligent system would be able to extract the underlying principles from just a few instances like humans often do.
Exactly. Think about how quickly you can grasp a new concept even from a limited explanation. That's the kind of efficiency that points towards true intelligence.
That makes a lot of sense. And what about scope? Where does that fit in?
Scope refers to the range of problems a system can tackle. Humans, for all our intelligence, are actually quite limited in our scope. We're great at language, social interaction, things that are relevant to our human experience.
Right.
But ask us to navigate the quantum realm or predict earthquakes with perfect accuracy.
Yeah, we're not so good at that.
Uh-huh.
We're basically just guessing.
Exactly. There are vast realms of problem solving where our human intelligence falls short. So when we talk about artificial intelligence, we need to consider not just how well a system performs, but also what it can perform on.
So it's not just about skill. It's about the efficiency of learning and the breadth of application.
You got it.
Okay.
And this brings us to another important point that Chollet makes. For now, the best way to measure intelligence, whether in a machine or a human, is to compare it to, well, us.
Yeah.
Are we that special? It's not about ego. It's about having a reference point. We can imagine all sorts of exotic forms of intelligence out there,
Right.
but we only have a concrete understanding of our own.
Right.
It's like trying to describe a new color. You inevitably end up comparing it to colors you already know.
That's a great analogy. So we're using human intelligence as a benchmark, at least for now, until we discover alien life forms with their own unique brand of intelligence.
Got it. And this is why Chawla is so wary of those AI moonshots, those moments when a machine beats a human at a seemingly complex task.
Right.
He argues that these achievements, while impressive, don't necessarily tell us if the AI system is truly capable of general intelligence.
Right back to that idea of gaming the system. It might just be very good at one very specific thing.
Precisely. We need to look beyond those narrow victories and ask ourselves, is this system really learning and adapting, or is it just exploiting patterns in the data?
And that's where those other sources you gathered come into play, right?
Yeah.
The ones about the SQL code and the gender identification challenge.
Absolutely. They perfectly illustrate the difference between skill and intelligence. That SQL code snippet you have, for example, it's designed to do one very specific thing.
Find the number of sisters someone has, but only if you know the name of their brother.
Right.
Helpful, I guess, if you're building a very specific kind of family tree app,
Yeah.
but not exactly what I'd call thinking for itself.
It highlights the limitations of task-specific programming. The system can execute that one task flawlessly, but it doesn't have the flexibility or adaptability we associate with intelligence. It's like a factory robot that can only install one specific part, incredibly efficient at that one task, but useless if anything changes.
Right. And then there's the snippet about evaluating different AI solutions for identifying someone's gender from a conversation.
This one's fascinating because it shows how even seemingly simple tasks can involve a lot of nuance and context, something current AI systems really struggle with.
One solution just relies on basic pronouns, which, as we know, can be very misleading.
Right.
Another tries to analyze the conversation for more inclusive language,
Yeah.
which is a step up, but still not foolproof.
Sure.
And then there's a solution that tries to account for non-binary identities, which adds a whole other layer of complexity.
Right.
It's like, how do you even begin to program that kind of nuance into an AI system?
It underscores the fact that human language is incredibly complex. True understanding goes beyond just recognizing keywords. It requires grasping the intent behind the words, the social context, even the potential for sarcasm or humor.
Things that are still really tough for AI to grasp.
Yes.
So we've got these impressive AI systems that can solve specific problems, sometimes even better than humans, but they're still missing something fundamental.
They lack that ability to learn efficiently, to adapt to new situations, to truly understand the world the way humans do.
So if skill alone isn't enough, how do we define intelligence? Well, Chawla has some interesting ideas about that. You're really making me appreciate just how complex and amazing our own intelligence is.
Yeah, it's easy to take it for granted, especially when we see those headlines about AI, achieving superhuman performance in this or that domain.
Right.
But as we've been discussing, there's a big difference between skill and intelligence.
Right. It's like my phone can calculate the square root of pi in a nanosecond, but it can't tell me if my dog is genuinely happy or just like faking it for treats.
Exactly. And this is where those two key factors that Chawla introduces, efficiency and scope, become so crucial.
Okay, so remind me again, what did he mean by efficiency?
When we talk about efficiency in the context of intelligence, we're really talking about how much data, how much experience a system needs to learn something new. Think about it like this. A human child can learn to recognize a cat after seeing just a few examples.
Right.
Whereas an AI system might need to be shown thousands, even millions of images of cats to grasp that same concept.
Right.
Humans are incredibly efficient learners. We can extract the underlying principles, the essence of catness, from a remarkably small amount of data.
Yeah.
And that's thanks in part to those innate priors that we talked about earlier.
Oh, those building blocks of knowledge that we sort of start with.
Exactly. Those priors give us a huge leg up when it comes to making sense of the world. But when we design AI systems with tons of pre-programmed knowledge, it's like we're kind of handing them a map of the maze before they even start exploring.
Right. They might race to the finish line, but did they actually learn anything about navigating the maze itself?
That's the key question. And it gets to the heart of why Chawla believes that measuring intelligence, especially in the context of AI, requires looking beyond just how one AI system performs on a specific task. It also requires understanding how efficiently it learned to do so.
So efficiency is about the learning process itself, not just the end result.
Precisely.
Oh.
It's about how much heavy lifting the system is doing on its own versus how much it's relying on pre-programmed knowledge or these massive data sets. And this ties directly into that second key factor that Chawla emphasizes, scope.
Okay, scope.
Yeah.
We touched on this earlier, but I'm still a little fuzzy on what it means in this context.
Okay, so imagine intelligence as this vast landscape. right?
Okay.
And each type of problem or task is like a different region on that landscape. Some regions are clustered together, language, logic, spatial reasoning. These are areas where humans tend to excel.
Right. We're good at human stuff, basically.
Right. But then there are these vast uncharted territories out there, the realm of quantum physics, the intricacies of protein, folding the complexities of predicting the stock market. These are areas where even the most brilliant human minds struggle to gain a foothold.
I know. I wouldn't want to bet my life savings on my ability to predict the stock market.
Exactly.
Okay.
And this is where Cholet's definition of scope gets really interesting. He argues that a truly intelligent system wouldn't just be good at things that are relevant to us,
Yeah.
to our human experience.
Right.
It would be able to tackle a wide range of problems, including those that are completely alien to us.
So it's not just about being a master of one trade. It's about having the potential to be a jack of all trades and maybe even a master of some that we haven't even discovered yet.
That's a great way to put it. And this brings us back to that fascinating paper by Wang and their team at Stanford, the one about hypothesis search.
Right. That one really caught my eye.
Yeah.
They were trying to get language models to think more like scientists, right?
Exactly.
Like generating hypotheses and testing them out.
They were trying to push beyond the limitations of simply training language models on massive data sets. Instead of just learning to mimic patterns in the data, they wanted to see if they could nudge these models towards a more active, a more creative form of learning.
So instead of just being really good at predicting the next word in a sentence, they'd be able to come up with their own ideas, their own theories about how things work.
Precisely. And their approach was really quite ingenious. They trained these language models to generate not just natural language hypotheses, but also to translate those hypotheses into executable code.
So instead of just saying, I think gravity works this way, the AI could actually write a program that simulates gravity based on its hypothesis.
You've got it. And then crucially, they could run that program and see if it accurately predicts real-world phenomena. It's like giving the AI the tools to not only hypothesize, but also to experiment.
That's brilliant. It's like taking the scientific method and baking it right into the AI's learning process.
Exactly.
Right.
And the really exciting thing is that this approach actually seemed to work. They found that by encouraging these language models to generate and test their own hypotheses, they were able to achieve some pretty impressive problem-solving abilities, even in domains that were completely new to them.
So it suggests that maybe, just maybe, this idea of teaching AI to think more like scientists could be a path toward developing more adaptable intelligence.
It's certainly a promising avenue, and it really highlights that crucial link between how we design our AI systems, how we train them, and what kind of intelligence we ultimately end up with.
It's not just about building bigger, faster computers. It's about understanding the very nature of learning and problem solving itself.
And that brings us to another critical point. Even if a machine can perform a task really well, even if it can generate plausible hypotheses and even write code to test them, does that mean it truly understands what it's doing?
It's like that saying, you can lead a horse to water, but you can't make it think about the hydrological cycle or something like that.
Precisely. And this is where that paper from Amirzadeh and their colleagues at Apple comes in.
Right.
They really challenge our assumptions about what it means for an AI to be good at math. Remember how we talked about those AI systems that can solve those complex equations?
Yeah, like they're the ultimate math whizzes.
Well, Amirzadeh and their team decided to dig a little deeper. They took a popular benchmark for evaluating AI's mathematical abilities,
Okay.
and they made a few subtle tweaks. Nothing that would change the underlying math, mind you, just slight variations in wording or presentation. And guess what they found?
I'm on the edge of my seat. Don't tell me these AI math whizzes totally choked under pressure.
It's funny you say that because it's almost like that's what happened. Even small changes in how the math problems were phrased completely threw them off.
So even though they could, like, crunch numbers like nobody's business,
Right.
they hadn't actually grasped those underlying mathematical concepts.
Exactly. They were relying on pattern recognition, not true mathematical understanding. It's like they had memorized all the formulas without ever actually learning what those formulas represent.
Which brings us right back to Cholet's argument about the limits of a lot of these current AI benchmarks.
Absolutely. He's skeptical that even the most sophisticated benchmarks we have today can really truly capture the essence of general intelligence.
And this GSM symbolic paper with the tweaked math problems, it really seems to back that up.
It certainly highlights the need for more robust, more comprehensive ways to measure AI's abilities. We need tests that can't be so easily gamed. Tests that truly assess a system's capacity for, understanding and reasoning.
But that's such a tall order.
Yeah.
I mean, after all, we're still grappling with the definition of intelligence itself. How do we measure something in a machine when we don't even fully understand it in ourselves?
That is the million-dollar question, isn't it? And it's what makes this whole field so captivating. Tollette's paper, it's not just a critique of current AI research. It's really more of an invitation to think more deeply about intelligence itself.
It's like by trying to build intelligent machines, we're being forced to confront our own assumptions about what it means to think.
Exactly. And that process of exploration and discovery, that's what drives this field forward.
Yeah.
We may not have all the answers yet, but by asking the right questions, by designing more insightful experiments and just being willing to challenge our own biases, we can at least inch a little bit closer to a deeper understanding of both human and artificial intelligence.
So where does this leave us then in this quest for general AI? Are we getting warmer, or are we still chasing a mirage?
That's the big unknown, isn't it? I mean, we've made incredible progress in recent years, but through that process, we've also uncovered just how much we still don't know.
Yeah.
Shell himself believes that true general AI might still be decades or even centuries away.
Yeah, who knows?
Right.
But even if we never quite reach that, grand goal of truly replicating our own intelligence in a machine, the journey itself has been incredibly valuable, hasn't it?
Absolutely. By striving to create these intelligent machines, we're gaining a deeper understanding of our own minds, our own creativity, and really just the very nature of intelligence itself.
So as we wrap up this deep dive into the world of AI and intelligence, here's a final thought-provoking question for you all to ponder out there. Chile argues that if we did manage to create a machine that possessed human-level intelligence, would we even recognize it as such?
It really makes you think.
Right.
Would we be ready to embrace it, to learn from it? Or would we dismiss it as just another clever algorithm, another impressive but ultimately meaningless feat of engineering?
It's a question that really challenges us to confront our own assumptions, not just about intelligence, but also about consciousness and about our place in the universe. And on that note, I think we'll leave our listeners to ponder those profound questions for themselves. Thanks for joining us for this deep dive into the ever-evolving world of AI.